Okay, thank you. Good morning, everyone. I'm excited to be here. Thank you for joining us. We have a packed agenda, as Rob has just gone through. In this talk, I am going to be talking about how Cloudera is helping our customers take advantage of a lot of the benefits of the cloud while simultaneously avoiding some of the pitfalls that can happen when you're migrating an application from the data center to the cloud. Now, first, it should not be a surprise to anyone in the room today that there's a major transformation going on in the IT world over the last few years. Public cloud adoption is surging. We see, more than 20% of total IT spend is in public cloud today, and that's increasing year over year. We're seeing this across industries and across use cases. We see AWS as being the leader of this at the moment. They are the largest, but they're not growing the fastest. We see that Microsoft, IBM, Google are catching up. They're growing faster than AWS. And overall, we're seeing a very large push from many customers to the public cloud. Now, this trend is quite prevalent within Cloudera's customer base. We see, as I mentioned before, across industries, so whether you're talking about retail, healthcare, financial services, and of course government, large adoption of cloud deployments. And we're seeing it across use case, from Customer 360 to risk mitigation or other analytic use cases. Overall, Cloudera's total cloud deployments are around 18%, so it's right on par with the industry average of about 18 to 20% adoption of the public cloud. And one more point on this, cloud is the largest or the fastest growing infrastructure component of Cloudera's customer base, growing at about 100% year over year growth from last year to this year. So it's starting off kind of small, but it's growing much faster than some of our other deployments. We're seeing a lot of push to the cloud. Now, this isn't really all that surprising. Hadoop was born for the cloud. This was the vision of our founders, the Cloudera founders, was that big data was going to be huge. It was going to require massive storage and infrastructure capabilities, and we were going to best achieve this by delivering it in the cloud. Now, back in 2008, when the company was founded, it was a little bit too early. The adoption rates from the last slide were much, much smaller at that time. So it took a few years, but we are now here. We're in the cloud era, and we are seeing a big push from our customers to take advantage of the power of the cloud. Looking at that specifically, the first thing that we look at is the scale of the cloud. The ability to store massive amounts of data and process massive amounts of data on essentially unlimited infrastructure is extremely compelling. The convenience of the cloud as well, the ability to have somebody else deal with and manage all of that infrastructure is quite compelling, rather than having to go to your internal IT department to manage that. The self-service nature that brings is also quite compelling. Once you have fully managed infrastructure, it's not too difficult to create self-service tools so that your individual departments can go and launch their own applications, self-manage, self-upgrade, expand the cluster to a larger size, etc. One of the biggest drivers, I think, though, is the speed. How fast can you deliver value? So time to value is a big driver of our customers towards cloud. And finally, the overall total cost of ownership can be quite compelling. So I'll talk in more detail later in the presentation about sometimes where we see that it's providing benefits and sometimes where total cost of ownership can be a bit more expensive. But generally, if done well and for the right applications, you can see at least a 50% reduction in total cost of ownership by deploying in the cloud. Now, cloud does bring its own set of challenges. As with anything, your mileage may vary. It is not too difficult to get yourself in a situation where performance is actually degraded enough that it's essentially breaking the application. You're no longer meeting your SLAs. It's possible to try to counteract that by throwing larger and more expensive instance types at the problem, and that could lead to bill shock. You could actually end up with a situation where it's more expensive to run in the cloud than it was with dedicated on-prem hardware. There are a number of other concerns, things ranging from application portability. How many changes do you need to make to your application to get it to run properly in the cloud? Migration concerns can be an issue. Security, of course. As Rob mentioned, we have a dedicated session on security later in the day, so we'll talk more about that in that session. Another concern is, well, when you don't manage the infrastructure, it's not in your own data center, you can't sort of physically go and see the servers where you're storing the data, it's possible that you run into a problem where you've kind of losing track of where your data is, how much data you have, and how you're managing it. So we see data governance problems sometimes be a little bit more prevalent in the cloud than they are on-prem, just because you're not in the practice of managing that quite the same way. Increasingly, we're seeing concerns from customers around data sovereignty. Sometimes this is by company policy. Sometimes it's by government regulation. In certain countries, they want that data to be stored in the home country. And other issues related to hybrid cloud, vendor lock-in, et cetera. So bottom line is, although there are a lot of benefits of the cloud, and there's lots of customers that are achieving those benefits today, Cloudera customers achieving those benefits today, there are some pitfalls to watch out for. So as we look at this, I'm going to talk through it in kind of a stepwise approach. And this is actually kind of how our product roadmap has evolved as well. If you go back a couple of years, the first attempts to get into the cloud were really kind of a lift and shift variety. So essentially lifting the platform out of the data center, putting it in the cloud. So I'll talk about how that's done and some of the tools we have to make that go smoothly. But you don't stop there. The second thing you're going to work on is now splitting that platform apart into its individual applications and optimize each one of those to give the best performance, cost benefit, convenience requirements for the individual applications. So you kind of lift it to the cloud, split it apart, optimize each application, and then you put it all back together again. So step 3 is essentially reconstructing what we call an enterprise data hub. Classically, we've thought of that as an on-prem construct, but we're now reimagining an enterprise data hub in the cloud where you are sharing not just data, but also schema, catalog, governance, security policy, et cetera, between applications running in the cloud. So it's kind of a stepwise approach, and we're going to talk through each one of these. First up is the lift and shift of the platform. There's a few considerations that I want to walk through. The first is that openness is actually even more important in the cloud than it was on-prem. All of the efforts that have been done over the last 5 to 10 years to create open platforms, open environments in the data center is not something that any IT organization is willing to abandon as they move to the cloud. It's even more important, in fact, as they go to the cloud because they don't want to get locked into any one cloud provider. So we're seeing a lot of demand in the market for customers to have a portable and cloud-neutral solution that they can run on multiple clouds in their data center, all without having to do retraining or changing the application just to migrate from one environment to the next. Second is that it's not just our platform, it's not just Cloudera's software, it's all of the other applications that run on top of that platform as well. We have over 450 certified ISVs that run on the platform, and when customers are looking to move their Hadoop workload, there's lots of other partners and other applications running on top of the platform that need to come along with that. And again, the requirement there is to have an open ecosystem and an open platform. And third, the hybrid open source software model that Cloudera has pioneered is equally important in the cloud as it was on-prem, helping to drive the overall community and drive the best performance. Now, let's look specifically at what a cluster looks like. In an on-prem world, what we typically see is that an organization will put all of their data into a single cluster backed by HDFS, and then they will build multiple applications on top of that. In fact, it's common to even see multiple tenants or multiple departments within the organization all leveraging and sharing the same platform. Now, there's a couple reasons why you would do this. First, related to cost, it is actually cheaper, of course, to build a single cluster and provision that cluster to match the peak requirements, peak resource requirements of all of the applications combined, rather than building a dedicated cluster for each individual application and having to provision each one of those to the peak. So there's a huge amount of savings you get just by pooling all of this hardware together. That's the first point. Second point is that it makes it much easier to share data. When you put all of your data in HDFS, it's easier for those applications to share data, whether that's interdepartmental sharing, finance data and manufacturing data, or whether that is sharing data between different kinds of workloads. Maybe you're doing some processing with the data engineering application, and then some analytics with the data analytic database application, and then serving that in a operational database kind of application. So it's generally cheaper and easier to build one large cluster and have all of your workloads and applications run within that cluster in an on-prem world. That actually flips around the other way in the cloud. In the cloud, what we tend to see is that it is actually cheaper and easier to run a single application per cluster. So from a cheaper perspective, the cloud capabilities give you the option to, they make it much easier to provision just the right amount of hardware, just the right amount of infrastructure, just the right amount of storage for each individual application, and therefore this over-provisioning concern kind of disappears, goes by the wayside. In that case, it's easier actually to share data by creating individual clusters for each workload, and then they can use the data in the object store in order to create sharing. So you still have the same benefits of sharing, but now by creating separate clusters, not only are you able to optimize the cost better because there isn't really any over-provisioning going on, you're also able to, as I mentioned, share data between the clusters quite easily through the object store. Additionally, it makes it possible to customize each individual cluster. So something that both on-prem customers and cloud customers would like to do is be able to specialize their cluster environment for each individual application. Whether that's picking a certain library, a certain version of CDH, or other mechanisms, it's preferable for them to be able to customize that, and the cloud makes that possible. So, as I said before, it flips around a little bit. In the cloud, we tend to see a much larger number of, it turns out to be smaller clusters that are all customized and specialized for each individual application. Now, let's go look in more detail at the object store. So a consideration here, generally we see object storage is preferable to HDFS. The overall benefits kind of outweigh the negatives of object storage. Performance is often good enough. Certainly it is higher latency and lower throughput, but you can often make up for that by throwing more instance types at the application to make up for the throughput limitations, number one. And number two, latency, well, sometimes it matters, sometimes it doesn't matter. For applications where latency is not all that important, a slower object store as compared to HDFS doesn't really matter all that much. Second, it's generally cheaper on a per terabyte basis to get object storage than it is for direct-attach storage. So the performance is good enough, it's generally cheaper, and another nice benefit of an object store is that it scales independently from compute. So a problem that a lot of our customers struggle with is trying to predict, okay, is my compute growing faster than my storage, or is storage growing faster than compute, and how does that vary from one application to the next? How is it going to be different next year versus this year? So their preference is to pull those apart, scale compute as it's needed, with kind of just the right size scaling of infrastructure, and scale storage in a similar manner. So a number of benefits. None of this is news here about why object stores are a good choice. One thing I'd like to point out, though, is that they do come with their own set of challenges. First off, it's not a drop-in replacement for HDFS. For example, S3, Amazon's S3 object store has quite a different data consistency model. It has an eventually consistent model instead of immediately consistent. So if you have an application that writes data to storage and then immediately turns around and reads that data could be lost. It could be, you could get an application error or incorrect result because you've let's say, read a stale value instead of the updated value. That's just a struggle or a challenge with this simpler, cheaper storage. That's actually not the case with ADLS, but it does vary from one to the next. Additionally, there's some other things. I won't go through the whole list here, but there's a flat directory structure enforced upon you with S3. ADLS does actually give you some hierarchical capabilities. And there's other differences between object stores, different access control models than you may have been used to, different maturity levels. All in all, there's some work to be done as you're porting your application from an on-prem direct attached storage model to a cloud object storage model. Lastly, there are some differences in terms of the overall support level within CDH. Now, the good news here is that we're making a lot of progress. In the last couple of releases over the last few quarters, object storage support is rapidly reaching maturity. This is particularly the case for S3, but we're catching up quickly with ADLS support as well, and we look at Google Cloud Storage as sort of the next thing after that. There's a few different steps. Again, I'll take a kind of a stepwise approach to how we've done this. The first thing we did was separate all of the compute modules from HDFS. And this was a lot of work on our side. From a customer perspective, it just works, on object storage. But we had to create different connectors inside of the HDFS libraries in order to enable access to S3 or to ADLS. And you can see over on the right that we've done that for pretty much all of the compute modules. For S3, the one that's missing is HBase, and there's some reasons, as we'll talk about later on, why operational database is a little more iffy in terms of its cost-benefit performance advantage on S3, but that is something we intend to add at some point. ADLS, we just, I think last week, had our first release that supported ADLS. We've added support for MapReduce, Hive, and Hive on Spark, and in subsequent releases we'll be filling that out to fully separate all of the compute modules and then make them work on the different object stores. The second step is actually to go and fill some of the functional gaps or performance gaps that I mentioned on the last slide. So as an example, for S3, it is not providing you immediate consistency out of the box, but we've built some capabilities within CDH to make up for that. So we have built essentially an enhanced consistency layer that improves the performance and gives you this read-to-write kind of capabilities so that we kind of mask that limitation of S3. So that was, again, our release last week just included that capability. It's called S3 Guard. Subsequent releases will add other kind of filling the gap capabilities in this area, such as providing atomic renames. Now, in addition to that, it's not just the data that we store in HDFS. As you remove HDFS, there's lots of other Cloudera services that run on top of that data, things like security and governance and backup and recovery, and all of that needs to work a little bit differently in object store model as well. And that is something that we're building out. Again, we're a little bit further ahead with S3 than we are with ADLS, but we will be catching up quickly on that. And then lastly, going to what I was talking about earlier, is that once you're building a cluster in the cloud and you have multiple clusters and they're all trying to share certain capabilities, there's lots of things that touch the object storage. Object storage is sort of the common construct or substrate where we're doing a lot of the sharing. So as you provide data, the permissions should follow that data. The data catalog, the data lineage all needs to follow the data. So there's a number of enhancements we're making to make that a reality. Another consideration to look at is that now that you have the ability to access an unlimited supply of cheap infrastructure, one of the first questions you have to ask is, how am I going to go about provisioning and managing all of that infrastructure? In the cloud, it's not possible to have an IT team. You wouldn't want to do it anyways. So you're going to have to rely on a lot of automation to do this, certainly to do it in a cost-effective model. You can't, for example, have an admin logging in to run installation and configuration scripts. It needs to be all happening automatically. Because once you get provisioned that hardware from Amazon or from Azure, the clock's ticking, right? The meter's running on that hardware, and you want to, as quickly as possible, spin up your cluster, run all the installation. If the workloads start to grow, you want to be able to grow and shrink very quickly. You need to be able to make good decisions in terms of selecting the right instance types for each service. As an example, there are certain kinds of instance types that you might use for data nodes, different ones for edge nodes, different ones for name nodes or master nodes. So all of that requires a lot of automation. I won't go into a lot of details here, but Cloudera provides two major tools to help with all of this so that our customers out of the box can take advantage of, first off, Cloudera Director. This automates a lot of the lifecycle management for a cluster in the cloud. Gives you a single pane of glass view for all of your clusters running in the cloud, and in fact in multiple clouds. So you can have a single tool and it will spin up clusters in Amazon, Google, or Azure, and that way you have a single tool. There's no need for retraining as you're managing a multi-cloud configuration. Additionally, it provides a lot of templatized setup for creating an environment for you to run all of your applications in a pre-optimized manner, again, so that you achieve the performance and cost advantages that the cloud promises to make that a reality, the automation the Director provides helps drive that. Second, Cloudera Manager. Again, this is a management tool that probably many of you are quite familiar with. We've been working and building out Cloudera Manager for 5 years. Its purpose in life is essentially to automate all of the installation and configuration of Hadoop services within Cloudera deployments. Our focus over the last 4 or 5 years was really on long-lived clusters. These were the on-prem clusters where you had actual assigned cluster cluster operations and administrators who were going to be installing and manually optimizing the services, setting up security, etc. Things work a little bit different when you're only going to run a cluster for a couple of hours. So we put a lot of new capabilities into Cloudera Manager over the last 12 months to streamline installation. Now you can spin up a 100-node cluster in, I think it's like 8 or 9 minutes. That's getting faster each release. As I mentioned before, that's critical. Once you're allocated all those resources, the meter's running and you need to kind of get in and out as quickly as possible. So there's a number of provisioning and automation enhancements that have gone into Cloudera Manager to make that happen. Another thing to think differently about in a transient cluster world is that the cluster is gone, it disappeared, once you've finished running your job. In that case, anything you would need from that cluster in order to understand the state, the result, to debug any failures, needs to be collected before you relinquish the cluster and saved off in an environment where you can come in and look at the diagnostic information or log file information at a later date. So again, all of that kind of automation, one could build it themselves, or you could leverage the tools to do that for you. So Cloudera Director, Cloudera Manager together create a powerful combination to provide all that automation and to manage all of the elastic and unlimited infrastructure capabilities. Now let's go look at sort of the second phase that I talked about. This is optimizing essentially each application one at a time for cloud environments. So this is kind of stepping up a layer. We looked at the platform overall. The platform, it needs storage, it needs infrastructure. Now let's look at the application layer and sort of what are some of their needs and what model of running in the cloud might be best for each kind of application. Now first, I've only kind of talked about the Cloudera platform, Cloudera Enterprise, but if we look inside of that, there are really 4 discrete applications. They're all a little bit separate. First, we have data engineering. This is essentially for processing data or modern ETL at scale. We have data science. Justin's going to come up and talk about that a little bit later. This provides exploratory data science and machine learning capabilities for data modeling. Analytic database helps your analysts analyze and explore all of your data, looking for trends. And operational database is built for data-driven applications to provide real-time insights in a data serving kind of operation. So above the platform, they all share one unified platform, but you have 4 discrete applications. And the needs of each of these applications is a little bit different. They can vary greatly from one application to the next. So if we look at, for example, the access patterns for data science and data engineering, and in fact even some of the analytic database use cases, you tend to see a batch style access pattern. It's a job that's going to run for an hour or for 10 hours, but it's a job that runs and is finished. That's what we call batch. This could be a transient thing. It's just literally a one-off. Somebody's doing some experimentation and they schedule a job and queue a job and then it runs and it's done. Or it could be a persistent thing. Every day at midnight we're going to run a 3-hour job. But generally they're batch in nature, whether they're transient or persistent batch. On the other side, with operational database, we see a lot more persistent. This is a real-time application that's running, and whether it's serving sort of live traffic data or something else, it's always running. And the utilization might vary, but it varies more based on kind of usage of that application. Right? There are more users running traffic, generating traffic during the day and during busy hours than it is during quiet hours, as an example. So there you see a lot less variance from a utilization perspective for operational database kinds of applications. On the performance side of things, again, operational database is a bit at one end of the spectrum where you have a lot more sensitivity to latency and data locality. So if you lose some of that, you're going to have a potentially much more impactful degradation to the overall performance, whereas data science and engineering tends to be much more lenient in that area, much more insensitive to latency and data locality. In security, it really depends on sort of use case, but generally speaking, we found a large number of data science and engineering workloads where security wasn't particularly important. Not to say that we wouldn't add full set security capabilities, but there's a number of people out there that, let's say, would be experimenting with certain data, and security may or may not be required for those use cases. So because of this, because each application is a little bit different, has its own access pattern and performance requirements in particular, that drives some of the decision making that you'll make when you're trying to decide how to migrate an application to the cloud and what kind of benefits are going to be possible. First, let's take a look at data science and engineering. As I mentioned before, there's a few different kinds of models. Generally, we see that most people, so our default recommendation, is to go with the transient batch approach. This is essentially where you're building up a batch cluster and then running the job and then immediately throwing that cluster away. So it's kind of a cluster on demand. Additionally, it's very likely that you can get a lot of benefits by using spot instances or sort of demand-based pricing. Spot can be sort of maybe half or even less as costly as sort of full guaranteed instances. And you can, like I said before, size it specifically for the workload. So if you need 50 nodes, you go get exactly 50 nodes. And you can size the node itself to be a thicker or a thinner node as needed. So that's the overall recommendation. There are other models. If you have more of a persistent batch model that gives you a little bit more control. In this case, what you would do is have a persistent cluster, but you would use reserved instances so that they're not sort of always running. And then when a batch job comes in, you can you can grow the cluster dynamically up to the capacity requirements that you need, run that job and throw that away. So you get a little bit more control by having the persistent cluster. Some of the setup will be already done. As you can imagine, when you do a batch cluster, part of the time is just to build that cluster up, right? So it might take you 15, 20 minutes just to run the cluster up, whereas if you already have the cluster running, it can be it's already running and you can avoid that hit. And then if you want if performance is particularly important, then what you would do is sort of load the data out of object storage and into HDFS, kind of preload the data, and then run in a more classic model. This is certainly going to be more costly, but if you have certain very high performance requirement kind of ETL jobs, then again that would be the better model to that. But you are kind of taking a hit because you have to spend up for the higher cost instances that will support HDFS. Okay. So the next application we'll look at is Analytic Database, and as Rob mentioned earlier, Justin's going to come up and talk about this in some detail, so I won't go through too much detail. But there's a couple different categories. First is within Analytic Database, there's ETL-like work, and then there's BI and analytic type work. It turns out the ETL is very similar to the data science and engineering, so the recommendations of these kinds of workloads are going to follow exactly what we showed on the last slide. But for BI and analytics, it's kind of a different story. Here, essentially, you have the same kind of concept, but the usage patterns are much more interactive in nature. So during the workday, between 8 and 6, you've got a lot more users on the platform, and they're going to want sort of as much capacity to achieve a interactive kind of response time. So you're talking kind of half second to 1 second response times being needed. In that case, the cluster may need to grow quite substantially throughout the day. It can start with maybe 10 clusters in the morning and then grow up to 50 or 100 clusters, instances per cluster by the peak time. Here, the model that we recommend the most would be persistent clusters. Again, because you always kind of have this system running, and it's generally better. There may be some cases where, okay, I'll just start the cluster, bring it up online at 9 a.m., but then you kind of have a service outage before 9 a.m. So there's not too many use cases, I think, where that's going to be effective unless you're maybe doing some dev test kind of work. So persistent clusters overall is going to be the better model. Again, if performance is a huge requirement, then we would recommend sort of preloading the data into HDFS and or Kudu. Again, Justin will kind of go into some more information about that later in the day. And lastly, we'll look at operational database. Now, as mentioned before, the performance and the persistency is maybe not the most well suited for cloud. And some of that is temporary, and there's other things we can do to the platform to improve performance and further optimize cost. As it is today, we would generally recommend operational database use cases, maybe kind of as a secondary approach for the cloud. So maybe some elastic spill to the cloud for extra capacity. Maybe as a low-cost kind of backup, you can back up your data to the cloud, dev test environments. Depending on what your overall goals are, there are some ways to take advantage of the cloud, but generally, if you're running a high-performance application, by the time you've spent up to get all the instance types and storage requirements to run it in the cloud, it probably would be cheaper to run that in your data center instead, so you get a better result there. Now, if it's a dev test and what you really want to do is just experiment without having to go make a long-term investment, then well, great. That would be perfectly fine to run that in the cloud. Okay, moving to the third section. So as I mentioned before, we lift the platform up into the cloud. We kind of pull everything apart and optimize each individual application. You can see there's lots of different choices you might make depending on the needs of that application and the needs of the customers, ultimately, the clients. What does the department need? How important is this application to be interactive or real time? What's the SLA requirements? The third thing we're going to do, and this is in an area where it's a bit more of a work in progress for us, is to kind of put everything back together and reconstruct this model where you have everything working together. Now this is particularly important because many of the most interesting problems are in fact a combination of things. A combination of SQL and predictive, of batch and online, whether that's multiple workloads or multiple departments working together, multiple data sets. There's lots of need for sharing, and of course this is why customers have been building, as I mentioned earlier, large multi-tenant, multi-application clusters. A lot of that, even though it had its limitations, there was a lot of value of that too, because it created one place to go and configure security, one place to go and configure governance, one place to store your data, etc. In a cloud world, we need to reimagine this a little bit, but the idea is roughly the same. You want to have common operations, common governance, security, etc., to support multiple applications, multiple departments, now all running in the cloud. Now, perhaps one day it could even be sort of in a multi-cloud where you have like half your stuff running in Amazon, half your stuff running in Microsoft, as an earlier step towards that, even within just one cloud platform, being able to share things. So there's a lot of roadmap work that we're doing here to make this much more of a possibility. In terms of where we are today, you can have, obviously the data stored in object store is shareable across clusters, and we have common management tools, whether that's CM or Director, to manage all of those clusters. So we have the common operations component, and we're just now building out things like common governance, and in fact we have common encryption as well. Common governance and common sort of authorization are a work in progress though. Okay, thank you very much. That's everything I wanted to cover today. Question, yes?
In the last factors in making a decision about these use cases, so when would you use EMR versus getting your own ECs and installing your own Cloudera app and all that other stuff, OS?
Okay, so I think your question is, when would it be better to use Amazon's EMR versus, let's say, not using the house provider's sort of Hadoop distribution and using something from Cloudera? Well, look, we would view EMR as a direct competitor, so I'll generally say not very often would you go with that. But picking that apart, let's see. What does EMR do? EMR was designed for a narrower set of use cases. Check up. Okay, we're okay on time. A narrow set of use cases. So for example, there's like no concept of persistence in EMR. Everything is transient. You can't upgrade a cluster. You can't do a whole lot to change it once it's running. Their idea is everything is transient, run the platform, run the workload, and then throw everything away. So if that suits you well, yeah, EMR might be fine. But if you are looking for anything that's persistent, or there's an advantage of creating a persistent environment, that persistent batch approach that I talked about a few slides ago, that would be much more well suited to run in a on a system such as ours. So there are some competitive differences here and there. They might have slightly more advanced features and certain capabilities. We would probably equally compare in other capabilities. Generally, from a strategy perspective, our goal is to be the #1 Hadoop provider, let's say overall. This would be certainly on-prem, and either be a #1 or a very strong #2 on every one of the major clouds, given sort of the biggest sort of hybrid cloud, multi-cloud platform. Any other questions? All right, thank you so much.